Awesome. So, good afternoon, everybody, or good morning, depending upon where you're tuning in from today. Welcome to the premiere episode of Velodyne's new webinar series, Velodyne Lidar Live, where we'll be talking to experts from every area of the mobility sector, discussing the latest advancements and all the ways this industry is transforming our lives and our communities in real time. I'm Pamela Gauci, your host for the next 45 minutes or so, and joining me is my co-host Mary, who's running slides in the background. And today I'm really excited to welcome Dr. Stefan Hrabar, CEO and co-founder at Emesent. But first, a little housekeeping before we begin. Let's take a quick look at our agenda so you know what you can expect today. We'll start off with a very brief overview on Velodyne Lidar, specifically looking at our puck light sensor. And then I'll move right into our interview with Stefan for about 35 minutes. And I'll save the last few minutes for audience Q&A. So be sure to use the Q&A button at the bottom of your screen to ask questions anytime during the episode. As always, we are recording today's episode, which will be available to watch on Velodyne Lidar's YouTube channel. So let's begin. Here you see a snapshot of industries utilizing our LiDAR technology. Now, the work Emesent does really covers two of these industries, and that's because their Hovermap mobile mapping scanner can be handheld or mounted to a drone. And that system is being used across a lot of other industries, including mining, construction, infrastructure, and forestry, just to name a few. So now let's take a quick peek at Velodyne's puck light sensor, which is an essential piece of the Hovermap payload. A few key specs to note are its ability to generate 300,000 points per second with a 100-meter range. Now for Hovermap, a critical payload feature is weight, and puck light checks in at an incredible 590 grams. That's just over 1 pound. So now let's see what that kind of data looks like. Here you see some stunning 3D mapping of a redwood forest in New Zealand. And this video really appealed to me because we're located here in Silicon Valley, which is just a few hours south of some of the oldest remaining coastal redwoods in the world. And if you've never experienced them firsthand, they are really magnificent to see. So this map is beautiful, but it's also incredibly detailed and highly accurate. So you can easily see how Emesent's Hovermap scanner can play a critical role in protecting our natural resources and our environment. And some examples of that would be managing the health of our forests or monitoring erosion across coastlines. And Stefan will be talking to us about some of the other kinds of use cases shortly during our interview. So now let's take a peek at Hovermap. Here you can see how the puck light is actually integrated into the Hovermap payload. In the center, you see Hovermap along with the puck light actually mounted onto a drone. And on the lower right-hand side, you see a standalone Hovermap, which can also be used as a handheld device. So now, I'd like to introduce Dr. Stefan Hrabar, co-founder and CEO at Emesent. Welcome, Stefan.
Hey, Pam, thanks for the introduction, and really excited to be here today to talk a bit about what we've been doing at Emesent.
Yeah, great. And I'm going to dive right into the questions because we have a lot of ground to cover today. Okay. For anyone not already familiar with Emesent, can you tell us a little bit about the company?
Yeah, sure. So we're based in Brisbane, Australia. We were founded in end of 2018. Prior to that, a number of us were with CSIRO, or CSIRO, that's Australia's National Research Lab, where we sort of started working on this, this technology of autonomy and navigation and mapping for drones. Then we spun out with some VC backing, and we've grown to just over 60 staff now. And that encompasses sort of expertise in robotics and obviously the expertise in drone autonomy, but also SLAM for both mapping and navigation. And we're also now growing into the data analytics sort of area. So our vision is really to automate the collection and analysis of critical data in these challenging areas, typically where there's no GPS or very hard to access.
And in the past few years, I imagine your customer base has grown. How has it grown since the company started?
Yeah, we're actually been pretty fortunate. So while we were still part of CSIRO, we were acting as a kind of a spin-in, and we had early adopters using the technology sort of in prototypes. So then by the time we launched the company, we had quite a bit of latent demand. So we had customers right off the bat. So around 50 customers in the first year, and that more than doubled the second year, and we're looking to double again this year. So that's sort of across many verticals, and I think we'll get to that a bit later. But yeah, big focus on mining for us. But then, as you've already mentioned, Hovermap can be used for a number of applications as well.
Yeah, and so I want to talk specifically about the Hovermap, of course. But first, I wanted to say congratulations, because Hovermap was recently won the Innovative Mining Solution Award presented by Australian Mining at the 2020 Prospect Awards, which is very exciting. And can you tell everybody listening a little bit more about Hovermap?
Yeah, sure. No, it was a great honor to get that reward and recognition. Hovermap, well, I've got one with me here. That might not be too easy to see if it disappears through the green screen effect, but basically it's a two-in-one system. As you mentioned before, it does both mapping and autonomy. So when it's mounted to the drone, we use the Velodyne sensor to do real-time navigation. So it's detecting obstacles around it. It's also estimating its position and velocity using the Lidar data and SLAM algorithm. So we don't need GPS, and it's storing all that data on board, and then we do a post-processing step to generate the final 3D results. So very versatile, two-in-one, mapping and autonomy can be used on a drone, off a drone, and yeah, everything's sort of built into the box.
And so what makes Hovermap stand out from some other mapping solutions, and how can it help a wide range of companies or local governments?
Yeah, I mean, obviously, and you'll see some examples playing in the background in the video of the data that's been collected by Hovermap. But the real unique feature of Hovermap is that two-in-one capability of being able to provide autonomy for the drone while being a mapping sensor at the same time. There are many mapping solutions out there, obviously using your sensors. Typically, they rely on GPS, INS integration to do the mapping. So to figure out where the device is, you need some kind of reference, global reference using GPS. Because Hovermap is a SLAM-based system, it doesn't rely on GPS, so it can be mapping indoors, underground, around complex infrastructure where GPS signals can typically be blocked. And then obviously providing that autonomy capability as well. And you would have seen in some of those videos that there's color information as well, so we can colorize the point clouds. We just have an add-on module, so there's a GoPro camera with a very rigid sort of quick release mechanism underneath that we can attach and use the GoPro footage to add color to the point clouds as well, which adds a bit of context for some applications.
Yeah, and so for anybody who's watching, who's an inexperienced drone pilot, and they might be thinking Hovermap is beyond their abilities, can you give us a sense of how easy it is to use?
Yeah, actually quite the opposite, because it makes drone flight easy and mapping easy. So I mean, that's been one of our core principles, is to simplify things and make them easy. And from the mapping perspective, you basically connect power, press one button to turn it on, and then press the button again to start mapping. Because it's SLAM based, you don't need to wait for any GPS signal acquisition. You can start using it immediately. And then when it's connected to the drone, it really helps to make the drone flight safe and easy. It's providing that collision avoidance. So the operator or the drone operator can focus on the mission, not so much on flying the drone. So if you're trying to inspect a cell phone tower or fly in a challenging environment, Hovermap's doing sort of the difficult part of the flying for you, and then the operator can concentrate on moving around an inspection camera. So yeah, it really actually makes drone flying easy, and it's a very simple device to use for mapping. And then our post-processing software is also very easy. You drag and drop your folder into our app, press go, and it generates the point clouds for you.
Yeah, and I can confirm that, because we do have a Hovermap that we use sometimes, and it is very easy to use. Yep. And can you tell us? I'm curious about maybe one of your personal favorite use cases for Hovermap.
Yeah, there are many, but I think this video will sort of illustrate a good example. So this was an incident which happened in a mine in Sweden. This is an underground mine, and they had an earthquake or a seismic event which caused a lot of the mine to collapse in places. And obviously this is a very dangerous occurrence. Luckily, nobody was injured, and there weren't people in those areas at the time. But for a mine to be able to go back into these areas and assess the level of damage and see if it was safe to re-enter, it usually takes them weeks or months to be able to slowly go back into these areas and check them out. And for every hour that a mine is sort of stopping production, it costs them hundreds of thousands of dollars. So in this case, they called in our partners in Sweden who have a Hovermap system, and they managed to fly many kilometers of these tunnels using Hovermap, going beyond line of sight. And you can see the point clouds that were generated. So this allowed them to assess the level of damage that had been occurred, and if it was safe to re-enter, and basically how much rectification would be needed to get the mine back up and running again. So definitely help with safety, because people didn't have to go into those environments, and help the mine get back up to production quicker, which saves them a huge amount of money. And gives them information that they otherwise wouldn't have been able to get access to.
Yeah, and so I want to talk a little bit about autonomy. And at Velodyne, the majority of times that we talk about different levels of autonomy, we're referring to autonomous cars, but there are also different levels of autonomy associated with autonomous flying. So can you walk us through some of the features you use to differentiate between levels of autonomous flying?
Yeah, and I appreciate that for a lot of your audience who are used to those driving levels of autonomy, sort of 0 through 5. There are equivalent levels of autonomy in the drone space, not sort of formally defined, but you can map. So for example, driving level 0 is, human is just driving the vehicle. So for a drone, that would mean a drone is just, a pilot is just flying the drone with full manual control. And obviously that as you go up the levels of autonomy, there's less and less input required from the operator, all the way through to full autonomy, where there's no driver in the vehicle. It can handle any situation, drive from A to B, no matter what's happening. So in the drone space, and particularly with Hovermap, we do have equivalent levels of autonomy for some of those. So our level 0 is basically, it's just acting as a mapping payload. It's not assisting the drone pilot at all. It's just sort of collecting data. Then what we call our autonomy level 1 is similar to the driving level 1, where it's assisting the operator. And that's where we have basically imagine a virtual bubble around the drone while you're flying. So you still have the operator on the sticks, but it doesn't let you get too close to anything. And you can adjust the size of that bubble during flight. So if you need to get closer to something, you can sort of reduce that. But if you want to keep a bigger safety distance, you can change that in real time during flight. And a key feature of Hovermap is that, and you would have seen in some of the videos, we actually rotate the Velodyne. So that gives us a full 360 by 360 field of view. And that's how we form that bubble. We've got LiDAR points spraying in all directions, keeping the drone safe, and obviously mapping in all directions at the same time. So your level 1 is kind of, you can still see the drone, line of sight flight, keeping it safe, but also using the SLAM and the LiDAR data to position the drone without GPS. So you can fly it underground into areas, a line of sight, or fly it up and down a tall structure where you might lose GPS. So that maps pretty well to driving level 1. And then what we call our autonomy level 2 is kind of our second release of autonomy, but it maps more closely to driving level autonomy 4. And in level 4, basically, you don't need a human in the vehicle, and the vehicle is able to get from A to B in certain scenarios. So for us, that basically means with the drone, you set a waypoint, press go, and the drone will navigate itself from A to B, avoiding obstacles, going beyond line of sight, and planning its path. So you don't need an operator. Obviously, it can't handle every possible scenario in the world, but it's very capable, as I think you'll see in some of the videos as well that we're going to be showing.
Yeah, so then you just mentioned AL2, and I was going to ask, it's recently launched. It's pretty amazing, and you've already talked about some of the features. Are there any other game-changing features you can mention?
Yeah, so the real benefits are that beyond line of sight capability, you don't need to see the drone anymore. So the way it's operated is once Hovermap's switched on and scanning, we stream a real time. So we're generating the map in real time, streaming that back to the operator. We have a tablet app which is used to control the drone or through Hovermap. So you get this real time point cloud on your tablet, and then you can use that to set waypoints in real time. And then Hovermap will self-navigate to those waypoints. So they're smart waypoints. They're not just is not flying blindly and dumbly to these waypoints. It tries to reach them, and if it can't, it will self-navigate around obstacles to reach them. Other smart features like smart return to home. So if if the battery's running low, it'll find its way home, even if it's underground in a tunnel or in sort of complex environment. And it's monitoring its own health. So if it gets into a really dusty environment and can't progress, or it can't reach the waypoint, you've put a waypoint in the middle of a rock face, for example. So it's a intelligence system which allows capturing data beyond line of sight, beyond communication range. Even if you lose the radio link to it, it'll keep sort of on exploring and going through its mission.
And I think we have a little bit of video to show us beyond line of sight. Can you tell us a little bit what we're seeing in the video? This is what you just described, right?
Yeah, so this is a typical application in underground mine, going to map a cavity, which is called a stope. So this has been blasted out, and they've removed the rock from this area. And they need to go in and sort of scan it to make sure that they've blasted out everything they intended to. So usually this is a very dangerous operation. A surveyor has to usually go to the sort of the top of this underground void and hold the scanner over the edge to try and scan it. But by sending in Hovermap means that the operator doesn't have to get anywhere close to these areas. And because it's flying in and flying around in this void, it really captures everything in a lot of detail. So there's no guesswork, there's no missing data. And like I said, this is using Autonomy Level 2. So the operator would have simply started it up, sort of tapped a waypoint approximately in the direction that he wanted to fly. And then Hovermap would have found its way into that void, scanned around, and then returned back. So you can see the flight path. You can see the level of detail that's captured. I mean, this really sort of blows the mining engineers and geotechs away when they see this level of detail that they've never been able to capture in these inaccessible areas before. Very valuable for them, allowing them to determine what's going on in those areas without obviously putting anybody in harm's way.
Yeah, it's pretty incredible. You get a really good sense of how grueling that environment is, and how you can't get people into those areas, right?
It's unsupported ground, so rocks could be falling down at any minute. Very, very challenging areas.
So then I imagine your testing for AL2 and Hovermap would be exhaustive. So how much of a beating does the system get while you're going through the testing process, and what kind of a testing process do you have?
Yeah, I mean, our engineers are pretty brittle with the system. They don't hold back, and you can see an example here, giving it some really challenging waypoints in amongst a forest. So just sending it up into the branches of a tree and just letting it pick its way through these really tight spaces. Here's another example in an underground mine. Again, sending it into one of these voids. In this case, there was water pouring down from the ceiling. So the drone sort of paused briefly at the water, and then carried on along this mission, and obviously, detecting everything that it needs to along the way. So you'll see some chains in the way, some thin wires hanging down. There can often be sort of mesh hanging from the ceiling as well. And one of the big challenges underground is dust, as you'll see now. So if the area is dry, the downwash from the drone can kick up dust. And obviously, worst case scenario, this can actually blind the sensor, so it doesn't know where it's going, and it can't reference, the SLAM system can't reference off the environment. So we have a smart fail-safe which detects scenarios like that and allows it still to return home. And again, one of the benefits of using the lidars, it can see through a lot of that dust, and using the dual return function, we can still see the walls even if the dust has been picked up in the first return.
And if the drone is on its way to a waypoint and the environment or the conditions changes, it can handle those changes on the way back, right?
Yeah, absolutely. Like I said, it's doing smart return to home. So it does have build a global map, so it knows the most sort of optimal way to get home. But if that changes along the way, like for example, if it kicks up a lot of dust and it realizes it can't proceed, it can backtrack and find other ways. So yeah, I mean, obviously, unless something extreme happens, like there's a blockage that it can't get through, it's not going to make it home, but it does adapt to changing environment.
And so hardware, can you give us an idea top to bottom of the hardware that is necessary for a mapping system like Hovermap?
Yeah, I mean, obviously the LiDAR's a key component. What's important is what it doesn't need. So unlike many systems, like I mentioned before, it doesn't need the GPS. when it's mounted to a drone, we do actually, and we can read the GPS signal from the drone, so we can use that data as an extra reference source and use that to georeference the maps in the world coordinate frame. But so yeah, the components are basically LiDAR, onboard compute to capture that data and process it in real time. We also use a fairly low-grade MEMS IMU, and that helps the SLAM solution. But again, unlike GPS INS systems, you don't need a high-end IMU. So yeah, pretty simple in terms of the components that are needed.
Yeah, and so you recently described Velodyne's puck light as being a quote unquote essential ingredient in helping Emesent create their game-changing technology. And so I have a couple of questions about that. First, why is LiDAR viewed as an essential ingredient?
Well, you obviously, if you're sending a system like this into the unknown, it needs to perceive its environment and build a map. So I mean, that's the critical role for LiDAR is doing the collision avoidance, navigation, and the state estimation using SLAM. Obviously, there are other ways of doing that. You can use vision and other sensors. For us, LiDAR has the benefit of being an active sensor. So if you're underground in a dark environment, it's not relying on external light source, so it can basically see in the dark. And the range that we get is like from the puck is up to 100 meters. So flying in those environments, we're not limited by the sensing range. Many other benefits as well, in terms of being able to see through. Actually, I think that's, you're going to be asking about sort of why the puck, and I'll get into that when we get to that question.
And I'll mention though, a payload, the weight is a big factor. How much does the Hovermap weigh in total?
Total weight is 1.8 kilograms. I'll have to convert to pounds for your audience.
I think it's a little under 4. I'm not.
Yeah. So again, extremely lightweight. Again, because we don't need the sort of heavy GPS INS, so we can reduce the weight. And for us, the puck light definitely makes sense because of that weight. Every gram counts on the drone and helps to reduce your power consumption, so you can fly for longer, or you can mount it on a smaller drone to carry the payload.
And yeah, so that comes to the other question that I had is why is Velodyne your sensor of choice?
Yeah, I mean, we've been using the puck for more than 4 years now. Through our early prototyping, we as soon as the device was available, we got our hands on it because we saw the benefits. So the key things that we already mentioned are weight. The power is fairly low, so we can use it on a device like this. The range that it's sensing range that it provides us. Cost is actually pretty good. The accuracy of the LiDAR is important to us because we're building those maps, and we've seen some of the details. So definitely meets those requirements. And then there are other things like the intensity values we get from the puck are great because it allows us to color the points by intensity and provide new insights to customers, so you can actually see things in the different intensity values. The dual return feature is great for penetrating through vegetation, mapping vegetation, or as I mentioned, in the dusty environments helps to penetrate dust. So yeah, just a great overall sort of combination of features, which makes sense for drone-based applications.
And you touched on this previously, as why does Emesent utilize LiDAR sensor data to provide Hovermap's collision avoidance and navigation capabilities rather than relying on GPS? Because the collision avoidance and navigation capabilities are pretty incredible.
Yeah, again, to get into those areas where there is no GPS, and the obvious ones are underground, but there are actually many areas that people might not sort of think of as GPS denied. Forestry is another one. Like when you saw it flying through the trees, usually if you fly in an environment like that, you really struggle to get good GPS. Flying amongst buildings, so in an urban environment, you can have challenges with GPS. So, using LiDAR plus SLAM allows us to map and navigate in those GPS denied environments. And then, as I mentioned before, LiDAR means we can do this in the dark and have that sort of that sensing range in all directions.
Yeah, and so we've talked about the hardware, and you're touching on the software. The hardware is pretty advanced, but the software pulling everything together is also very complex. Can you talk a little bit more about SLAM and what it takes to pull all of those layers of rich data together to create those beautiful maps?
Yes, I mean our value is obviously really in the software. That's where we add value from the autonomy through to the SLAM-based mapping and then analyzing that data to derive insights for our customers. I mean, SLAM is obviously a big topic. I think a lot of people are familiar with the principles of SLAM. I mean, I can't, that's another whole lecture sort of on how SLAM operates, but for those who are not aware of it, I suppose thinking about sort of in the simplest form, we're using the LiDAR data to identify unique features in the environment. And as the device is moving, it's seeing those unique features again and again, and using those to self-reference and figure out how it's moving relative to those features. So I suppose in the simplest case, imagine you're standing facing a wall, you're seeing something 2 meters away. A second later, you've moved forward and you see the same wall, and it's now 1 meter, so you've moved 1 meter over that time. So you can sort of self-reference versus that. So yeah, with LiDAR, it means we basically picking up thousands of features in the environment per second and tracking those and monitoring them and using that to self-reference to figure out how the device is moving relative to those features. So it does mean you need to be seeing stuff. I mean, if you fly, very high where the LiDAR is losing, not seeing anything, SLAM's not suitable for those applications. Or for example, if you fly into a very sort of flat, barren environment where everything looks the same, it won't have any features to track. Or if you flew in a very smooth environment like a concrete or steel-lined tunnel, in that dimension, everything would look the same. So I mean, it does have its limitations, but SLAM's come a long way over the last couple of years, and it's built into many devices. I mean, your iPhones now with the LiDAR built in as well use SLAM, either using LiDAR or using vision. So yeah, it's becoming fairly commonplace to do mapping and estimation of how things sort of position and moving in space.
Yeah, and so shifting gears a little bit, I'm curious, where did your interest in autonomous navigation and robotics come from?
Goes back more than 20 years, I suppose. So my background was first in undergrad in mechanical engineering, and I actually was interested in doing animatronics for visual effects for the movie industry. Wanted to get into that and realized that there wasn't much, you couldn't go and do a degree on animatronics. It's more sort of apprenticeship, and I realized that there wasn't any intelligence in it either as well. So it's just a puppet at the end of the day. So started getting interested in robotics, had a look around and ended up going and joining a PhD program at USC in the States. And from the day I joined there, I started getting into drones and automating drones. I did my PhD on that topic. That was, like I said, 20 years ago. So I did my PhD on that. And then when I joined CSIRO in Australia, I carried on doing the same kind of thing. So yeah, I've always had that interest in flying things and robotics, and kind of drone autonomy brought those two fields together.
And then ultimately, I noticed you mentioned film. Emesent has done some work in films, right? The Hovermap's been used, yeah.
Yeah,
which is cool.
Unfortunately we can't show all the good things, but there's a customer who have XM2, so they're a great customer, and they fly the big cameras for most of Hollywood blockbusters. And in those instances where they're flying the drone to capture the video, they often then also need to capture a 3D representation of that scene that they can pass on to the visual effects teams to create the digital backdrops basically for those movies. So what they do now is, in between shoots, they'll take the cameras off, put on Hovermap, and do a quick flight to capture those scenes or carry it around sort of handheld. So yeah, it's been used in the latest Star Wars, latest Fast and Furious, latest James Bond. It's on set with Mission Impossible at the moment, and a couple of others, and Mandalorian. So yeah, no, I love seeing what they do with the data.
That's so cool. So, and you mentioned, you've been doing this for, a couple of decades now. Why in 2018 did you decide that that was the right time to form Emesent?
Combination of timing and the technology readiness of what we've been developing, I suppose. So, we've been doing really world-leading research within CSIRO for a number of applications on the drone autonomy side, and then we had sort of the SLAM capability developed in parallel by another team in CSIRO. So we kind of put those two together and realized the power of having SLAM and autonomy with LiDAR. Around the same time, we started getting interest from mining companies when they realized the potential of the system to fly into these areas underground. So yeah, a couple of combinations of sort of timing. We had interest from investors. For me personally, I'd been with CSIRO for more than 10 years and was looking for a new challenge, and really wanted to make sure that we could generate impact from some of the stuff we've been developing there. And had a great co-founder, Farid. So he's my CTO and co-founder. So we'd been working together in CSIRO for the last 10 years, and we're really both sort of passionate about what we're doing and wanted to sort of bring it to the world and have impact. So yeah, just good timing.
So Emesent 2021, is that what you envisioned when you started in 2018, or is it different from what you first envisioned it would be?
Probably what I hoped it would be. I didn't really expect, for it to go as well as it's going. But yeah, no, it's I definitely know. If I'd imagined we'd be doing this well, I think it would have been much easier to make the decision to do it. No, it's been an incredible journey, doing amazing things. Obviously, growing a lot of challenges, but yeah, really enjoying it. So yes.
Very cool. Yeah, the changes in the industry the past few years are pretty incredible. So the timing is good.
Yeah. I mean, obviously drones are being used regularly in many industries. Autonomy is being recognized, and the benefits of autonomy in drones and others. So yeah, a lot of sort of, as I said before, timing, things coming together. I think we've been fortunate.
Right, so I have time for one more question before we move to audience Q&A. What can we expect from AL3?
Yeah, great question. So again, maybe not mapping directly to the driving levels of autonomy, but for us, what AL3 means is sort of single-click mission execution, where the operator doesn't need to put down any waypoints. The system knows that it's in, for example, stope mapping mode. That's the underground void. So all you do is put the drone on the ground, press go, and it will keep exploring until it's found that void, and fly around until it knows it's seen everything that it needs to at the right sort of resolution and point density, come back and land. Or if you're inspecting a cell phone tower, the operator would just press go, and the system knows that it's trying to achieve that objective. So there's no sort of operator input required. So those are the kinds of things we're working on for our level 3 autonomy.
Very cool. So I'm gonna move on to some audience Q&A here. So I have a question about older technology being retrofitted, and specifically things like farming equipment.
Yeah, so we have a lot of interest from farming and mining equipment, etc., for automating. Definitely what we've got can translate to those environments. There are other challenges, and in some cases it doesn't make sense to use SLAM if you've got open skies and GPS. But Hovermap, because it's modular, you can mount to those vehicles. So already many customers using it in a passive way, mounting to vehicles. So we have a number of accessories which allow you to mount Hovermap to vehicles and other things. So we've got a magnet mount, suction cup mount. So you can retrofit to those vehicles and use it as a mapping device. But to then automate those devices, obviously we'd have to hook into the automation system for those vehicles.
I have a question here about what absolute and relative accuracy do you see on concrete or hard ground from the drone?
There's always going to be an accuracy question. It depends on the flight height. So range noise is a function of range. So typically if you're flying in sort of 40-meter altitude, over a hard surface, within the range specs of the Velodyne, which is plus or minus 3 centimeters. Like I said before, if you're flying over an airfield or something, which was just an endless flat tarmac, SLAM would be sort of challenges in those environments. But over most urban environments where there's structure around, what you'd get is that range resolution from the Velodyne. And then there are tricks to clean that up a bit, fit planes, etc. So when we're scanning close to things, we can get down to sub-centimeter accuracy, relative accuracy.
So I have a couple of questions I see about forestry specifically.
Yeah.
One of those is, how do you calculate stem volume and volume of branches?
So we don't do that ourselves. Our Hovermap produces those point clouds, but we have customers who are using it to then use that data to do DBH, which is sort of the diameter of the trunk. And they have their own software for doing that. So definitely have a look at some of our webinars which focus on forestry. Interpine is one of our customers in New Zealand, and they're doing great things with Hovermap for forestry management.
And so I see another question on forestry. Can you speak to the use of Hovermap in forestry mapping and whether geolocation of the point cloud is integrated?
Yeah, so for under canopy, where it's purely SLAM-based, geolocation without GPS wouldn't be possible. So you'd have to have some kind of control points in the environment. So the way it's typically used is to scan sample plots. So they walk around with it or fly with it, scan those plots, and then they use that to estimate or extrapolate to the rest of the forest. Can be used above canopy as well, and obviously we can penetrate down through the canopy fairly well and combine above and below. If we're flying above, we can use the drone's GPS to georeference. But if it's under canopy, just using SLAM, then you do need survey control points to globally georeference.
Okay. So, and I see a few different people asking questions about how it might be used in firefighting applications.
Yeah, great question. We don't have any active firefighting use cases at the moment. The way I think it could be used as potentially as a location device. So if you're going into a building, we do have a real-time display of the map as it's being built up. So if you had a Hovermap mounted on a backpack, which we do have a backpack accessory, you would see a map of the environment being built up as you're navigating through it. And then if if it was dark or smoky and you needed to get your way out, you could use that map to basically retrace your steps to get out. Obviously, if you've mapped that building prior to the event, you'd have an idea of what rooms there were and how to get around in the building. So it could be useful if you could use it to map those buildings before their event and then during the event to help navigate through them.
And I have another question here about Gopro. How does the Gopro color mapping work, and was that developed externally or internally?
Yeah, so obviously to get the projection of the color onto the LiDAR, there's very detailed calibration between camera and LiDAR. So we have a semi-automated process to do that extrinsic calibration. So figuring out how the camera's mounted relative to the LiDAR. So once that's calibrated, we can, because of the way we've designed the mount, you can take the GoPro on and off, and it's very rigidly secured every time you put it back on. So record video, record Hovermap data, run it through our SLAM processing engine, and then there's a second step which then takes the image frames and uses that to project onto the point cloud. And that was developed by ourselves together with colleagues at CSIRO.
Awesome. So I do have a question. If somebody's wondering if they collect data with another device with Velodyne, can they use your software to manipulate that data?
No, not at the moment. It's quite specific to the types of data we get for SLAM. Timing is critical, so everything has to be very well synchronized between the IMU and the LiDAR, and it's expecting data in a certain format.
And so I have somebody asking, we have a lot of questions, asking about intensity values. Do you have intensity values? Yeah,
so the puck produces intensity values. And like I said before, they can be really useful for certain applications. I mean, if you color by intensity in an urban environment, it's kind of looking at a a grayscale image, or you can change the color scale. But for example, in underground mining, it allows the miners to actually see quartz veins in certain rocks, so they can actually see where the veins are, and other kind of mineralogy. So it's very useful actually as another sort of indicator of without color, you can still derive a lot of insights from the intensity values.
Great. So I do have somebody asking about dust. If you can speak to that, I know you talked about this a little bit earlier, but the dust in some of those environments is pretty intense. And how does the system deal with that?
Yeah, so like you saw in the video, a lot of dust. For it to maintain a good SLAM solution, so figuring out where it is, it needs to at least see through the dust to see the walls of the tunnel. So because we're fairly close to those walls, it does penetrate them really well. The other challenge is it might see the dust as an obstacle. So if you're doing collision avoidance, suddenly there's a big cloud of dust. It'll think, oh, I can't go there. So that's where it gets tricky. We have to sort of have a compromise between rejecting dust without rejecting other small obstacles. Like if there was a thin wire hanging, how do you know that's, not to ignore that, but still to ignore the dust? So yeah, we got lucky, got some very smart guys, and they've done a lot of work in sort of optimizing and tuning that and using different sort of techniques to figure out what is dust, what's not dust. As long as we're seeing the wall, we can still estimate where we are, and then we've got to figure out what's an obstacle and what's dust. The guys were underground again last week, and some of the environments, I mean, I think the maximum visibility was about 8 meters, and the system was still performing. So yeah, it does have limits, obviously. If it's too dusty and it can't see the walls anymore, that's when you'd be in trouble.
Yeah. So I have 2 more questions to ask. I know we're running out of time. Somebody's asking, your product is saving lives and reducing risk in dangerous occupations and jobs. What has the social and legal climate been like?
From a social perspective, again, I mean, I'm talking about mining because that's where we have our sort of biggest customer base. From a safety perspective, definitely see the benefits. I think to me, what's exciting is the fact that because they can now get data in areas that they couldn't before, it's allowing them to potentially change the way that they mine. So fundamentally change some mining techniques. If you're starting a brand new mine and you know that for the life of that mine, you're going to be able to get really good data, any part of the mine, anytime, you can actually make some key decisions on how you design and plan for that mine. And that can include consequences for the environment. So you might be able to do it in a way that's sort of more environmentally friendly, not sending people into the mine as mines become more automated. So yeah, I mean, I certainly hope there's sort of going to be that social aspect. From a regulations point of view, obviously drones are very heavily regulated in many parts of the world for good reason. In the underground space, and it varies from country to country, the airspace regulations don't always apply underground. So again, that's a good reason for doing a drone autonomy underground. It's very challenging, but it does allow you to do that sort of beyond line of sight flight capability. And then for above ground, obviously, yeah, country to country, you need to get the necessary approvals to fly beyond line of sight. But having a system like Hovermap on board can actually help in those cases because it is an extra level of safety. It's doing collision avoidance. It's robust to GPS outages. So you can use that as sort of one of your safety cases and arguments to allow sort of drone operations that probably otherwise would not be allowed.
All right, so we're just about out of time. I have time for one more question from the audience, and I have a couple of people asking about drone compatibility. What kinds of drones are compatible with Hovermap?
Yeah, great question. So to start with, we adapted our autonomy for DJI drones, starting with the M600 and then the M210 and now the M300. So those are all compatible. We're now adapting to non-DJI drones with, for example, with Pixel autopilots. And expecting to release first products around the end of this quarter, and working with a number of different manufacturers in the US and Europe. Obviously in the US, there's some issues with using DJI drones, especially for sort of government and defense applications. So big priority for us is to get that released for other platforms as well. Yeah.
Great. So we're unfortunately out of time. And if we didn't get your question, that's not a problem because you have our contact information right there on your screen. So you can reach out to us directly with any questions about Hovermap, AL2, or Velodyne's Lidar sensors. Again, this webinar recording will be available to view on Velodyne Lidar's YouTube channel. I want to thank Stefan again for joining us today. I know it's early in Australia, so thank you, Stefan.
No, no problem at all, and really appreciate the opportunity and great way to kick off the year, and looking forward to the rest of your webinar series as well. So yeah.
Thanks, thank you. And I also want to encourage our viewers to check out Emesent's website. That's emesent.io. There are a lot of just really outstanding videos and also some really great webinars that dive a little bit deeper than we were able to go into today about Hovermap and AL2 and Emesent's technology. So check it out for sure. And I want to thank the audience for joining us today. And if you're interested in learning more about the latest developments and applications in the mobility industry, be sure to join us on February 26th when we'll be talking to Asad Lassani, the co-founder and CEO at Blue City Technology. We'll be talking about the work his company is doing today with city governments to make traffic systems more intelligent, efficient, and safe. So I hope you'll join us next time. Thanks, everybody, and thank you again, Stefan.
Thanks, Pam, and thanks
All right.
everybody for dialing in.
Bye-bye.